So this is going on page 102. So I can figure out how to. Like, I'm so spoiled being able to just be in my own room all the time. All right, page 102. Page 102. I'm going to teach in slow motion today. All right, so this is you're going to title this arc length. I guess that's good. It slows me down. Length. Wow. And sector area. And it's also going to look like a second grader wrote this. So, arc length and sector area. Okay. So arc length and sector area are something that we did in geometry, right? There's a formula for it. Even when we did it, I say, hey, there's a formula. I show you. I usually put yuck and say, don't use this. We're going to use a proportion instead because it makes way more sense as a proportional relationship. So same thing here, but when you use radians, it actually makes it a little bit better to use the formula. So we're going to look at it as a proportion. I'm going to show you where the formula comes from and see why when you're using degrees, the formula is a lot yuckier, but when you're using radians, it's actually a little bit better. So let's talk about the difference or what these things really are. So starting with arc length. Oh my goodness, this is going to be interesting. Arc length. The arc length of a circle is just a piece of what? What is the arc length a piece of? Circumference, okay? So this is just a part of the circumference. Okay, if I'd have known it was going to be this bad, I would have just used the document camera, but it's a little too late now. Part of the circumference. Yay. All right, so what is the circumference formula? 2 pi r. So circumference is equal to 2 pi r. All right. The other things that we're going to need to use is what actually represents arc length, and that is a lowercase s. I don't know why it's an s, but it's an s. Okay? Because there's lots of reasons why it shouldn't be an L, but it's an S. So this is the arc length. And then theta that we're going to use is the central angle. So that's just angle, so I don't have to write the word. Writing is difficult. In radians. Okay, central angle in radians. Everybody with me? So if I have a circle, here's my circle. Remember, the central angle is just an angle whose vertex is at the center of the circle, right? If I'm standing in your way, just tell me to move. This right here is theta. Okay, it's the measure of the angle. This is the radius of the circle. And then this part right here is S, or the arc length. Everybody with me? So if I want the length of the arc, which remember, for a unit circle, the length of the arc is the angle in radians. Okay, if the radius is 1. That's the whole idea of what radians is. But if it's not a unit circle, then I can still find the length of that. So if I look at this as a proportional relationship, I know that the arc length, which is S, is part of the entire circumference, which y'all already told me is 2 pi r. Y'all agree with that? So it's part out of the whole, just like you make a proportion. So in order to get a proportion, and know that that's an S, not a 5, because I can't really make it very smooth. I have to set it equal. I have to have 2 equal ratios. So it's a part out of the whole, part out of the whole. So that's where the actual angle comes in. So the angle here is a part of the entire rotation. So that's theta. So we've got part out of the whole, part out of the whole. Remember, this is in radians. So one complete rotation in radians is how much? 2 pi, right? So 2 pi. So think about that. If the radius was 1 and it's a unit circle, then these look the same and this is theta because that's how you get your radians, okay? But if I want a formula for arc length here and I want to get the arc length by itself, what do I do to get S by itself? Multiply both sides by 2 pi r, right? Okay, so the part that I want first. Then I'm going to get S equals 2 pi r times theta over 2 pi, right? So what happens here? Anything cancel out? The 2 pi's, right? So I can think about this over 1 if that's necessary. 2 pi cancels out with 2 pi. So you just get that the arc length is equal to r theta. Radius times the angle in radians is your arc length, okay? That's your arc length formula. It's that easy. So that's better than a proportion because you got extra stuff in there and you don't have to actually cross multiply and all that kind of stuff. You with me? That is your arc length formula. So let's do a couple here. Maybe. Let's see. So example number 1. I'm going to give you that the radius is 5 inches. I'm going to give you that theta is pi sixths. And I want to know what is S. So this is S equals r theta. This is a plug and chug problem, right? You've got the radius, you've got theta. So S equals the radius, which is 5, times pi over 6. So what's your answer? 5 pi over 6. Does this have units on it? What are the units? Inches. Because it is arc length, okay? Your units are inches. Because that is not a radian, although it looks like a radian answer, that's not radians, right? It is the actual arc length, so it is in inches. Everybody with me? That easy? Okay. Let's do another one. I'm going to give you this. Actually, I'm going to have you do this one. I'm going to give you that the radius is 4. And theta is 18 degrees. And I want to know what the arc length is. Okay. Is 18 a special angle? It's not. So you got to do a little conversion because you can't just plug in the 18 degrees. It has to be in radians. If I'm going to convert from degrees to radians, what do I multiply by? Pi over 180, right? Is this a pretty easy one? What do you get for theta? Pi over what? 10. Okay. Everybody agree with that? Then we just substitute that in. and get S equals R theta. So my radius is 4 times theta, which is pi tenths, which means that my arc length is what? 2 pi over 5. Remember, always all in one fraction, and my units are inches. Easy enough? All right, one more of these, and then we're going to talk about the sector area. This time, I'm going to ask you for something different. So for the third one, I'm going to give you that the arc length is 12 centimeters, and that the radius is 10 centimeters, and I want to know what is theta. So this is just like any other problem that you ever do, whether you're in math or science or anything. You write down the formula, you substitute in what you know, right? So S is equal to R theta. And which pieces do we know? S, right? Well, I'm going to plug in 12 for S. Do you know the radius? 10. Do you know theta? No. That's what you're looking for. What do you do to solve for theta? What? Divide, yeah? So theta is equal to 12 divided by 10. What does that reduce to? 6/5? Oh my goodness. Sorry, I have to have my ringer on right now, and it's probably ridiculous things that don't mean anything anyway. Yeah. Okay. Then what are my units on this? It's radians, right? Because it's in degree. I mean, it's not in degrees. It's an angle. On your assignment, it does say to the nearest thousandth, so you'll have some decimals. I just didn't want to worry about y'all worry about getting calculators right now and putting them back because it's really not all that necessary. What would this decimal be? That's pretty easy to see. What's 12 divided by 10? Come on. 1.2. All right, so 6/5 is a fine answer, but you're going to actually multiply pi in some of these as well. But 1.2 is fine, and it would be radians. But you have to make sure that you understand, you know, when you have radians and when you have inches or whatever. It's an angle, so I can't make a circle with this pen. It's going to drive me crazy today, but there we go. We good? Any questions? Simple formula. You substitute in what you know. Make sure you're in radians. Y'all can handle this, okay? Now, sector area. Let me go to the next page for that. Y'all still have room on this same page in your ISN, right? Okay, if we need to go to the next page, let me know. It's not that big of a deal. I just don't know where you are on this stuff. So, sector area. Oh my goodness. That's an E. E. That is a part of what? What is the sector a part of? It's what? You're going to have to talk out louder. What's the sector of a circle? It's a part of a what? Do you know what a sector is? How many of you have no clue what a sector is? Wow, I really suck as a geometry teacher. Okay, so your arc length, pretend like that's a circle because apparently I can't make one at all. Arc length is part of the circumference. Your sector is like a slice of pizza. It's a piece of, if the arc length is a piece of the circumference, the sector area is a piece of what? It is a piece of the circle, but what about the circle? Area. Okay. It is part of the area. Oh, pen. Y'all are just depressing me. Well, I said this, you guys say it louder, like I can't hear you. I hear some whispering, but scream it out. Be proud of your answer if you know it. Because you're making me feel really bad about myself up here. Okay. Part of the area. You can write of a circle if you want, but I'm giving up on writing, so part of the area of a circle. Well, I probably should. Of a, oh, look, if I draw a little one, apparently I can do it. Part of a circle. Whew. Okay, so Again, theta has to be in radians, okay? So that is the central angle in radians. The area formula of a circle is what? It'll make me walk out the room if you can't give me this one. Area formula of a circle. You can go ahead and start. Just put it face down. I'll come get it in a minute, but you can start with this. Sorry, I didn't realize you were sitting there. Just stick them both face down. I'll come get them. We're on page 102. What's the area of a circle? 2 pi r circumference, pi r squared. Thank you. Pi r squared. Y'all know that. Give me a break. Pi r squared. Okay. We're just going to use a capital A for this sector area because that's what seems to happen in a lot of these things, but I don't want to just use an A here. That's why I have that subscript so we know what's going on. So we start with a little proportion again. Right? The area of the sector that I'm looking for is a part of the entire area of the circle, which is pi r squared. Right? And so just like on the other one, for arc length, I have to know how much of the entire rotation I'm taking up for this part right here, right? So this is theta over what's an entire rotation in radians? 2 pi. Okay. So I'm trying to get the area of a sector. I need to get that A by itself. So I'm going to multiply both sides by what? Pi r squared, right? I got to get this out of the denominator. So I'm going to get that the area is equal to pi r squared times theta over 2 pi. Now things don't cancel out quite as nicely on this one as they did on the other one. But if I put this over 1, what does cancel out? The pi's, okay? And even though in the end we would want our answer all in one fraction like we do for radians, their formulas are better when they're not necessarily in one huge fraction. So this 2 in the denominator really means I can multiply the whole thing by what? How do I kind of separate it? Dividing by 2 is the same as multiplying by what? 1/2, okay? So my area formula really is going to be 1/2, because that 2 is in the denominator, and then I'm left with r squared theta. There is your area of a sector formula. So your arc length is just S equals r theta. Your sector area is area equals 1/2 r squared theta. Okay, so let's do an example of this one. Probably just do one example of this, and then I'm going to give you. So I think we're on example 4. I'm going to give you that the radius is 6 inches, and theta is 120. And I want to know area of the sector. The question would clearly say area of a sector, so you know what you're finding the area of. We just don't necessarily need to write that. Hopefully you know that that's what you're doing right here. All right, so our area formula equals 1/2 r squared theta. All right, but what does theta have to be in? Radians. Okay, so remember, you can think about the pieces that you know, right? We have special angles, 30, 45, and 60. Of those, which is the biggest one that divides into 120? 60. What is 60 as in radians? Pi thirds, right? How many 60s does it take to get here? 2. So theta in radians is actually what? 2 pi thirds. Oh, thirds. We good? See how you think through that? Yes, sir. Radius? So that's a 6. 6 inches. I know, it looks like a B. I know, I'm sorry. It's 6 inches. I know, I was like, radius, really? No, it's 6. doing the best I can up here. Yes, please stop and ask me if you do not know what the heck I'm writing. All right. Everybody else good? Everything? So I'm just going to substitute in what I have. A equals 1/2 times 6, not B, 6 squared. Theta is 2 pi over 3. All right, so can I take half of 6 and then square it? No, please, Lord, don't do that. What is 6 squared? 36. So, and then I can square 6 and then take half of it. What's half of 36? 18. So now I have 18, maybe, 18 times 2 pi over 3. Can I reduce before I multiply? I highly suggest you learn how to reduce before you multiply. I mean, I could square 6, multiply it by 2, and get 72 over 6 and then go from there. But if I just kind of reduce along the way and, you know, little fraction stuff here, I can put that over 1. 3 goes into 3 once. Goes into 18 6 times. So in the end, what is my answer? 12 pi. Okay? So 12 pi, what are my units here? Inches squared. Good, because it is area, right? That is the area of the sector. When you go in here to use the calculator, do you use 3.14? No. You always use the pi button, right? Pi button in there is thousandth know how to round. Okay. Are we all good? Any questions on either one of those things? Very simple. Know your formulas. You're pretty much just substituting. Make sure you're in radians and just substitute in whichever piece you have and then solve the problem and you'll be fine. Okay? We all good? Any questions? Okay. And I know those of you that were taking the quiz, you might probably have to go back and watch the beginning of